Hey guys, so today we'll be solving the question double a number represented as a linked list, which is the LeetCode contest and the LeetCode contest question. So let's look at the question. You're given the head of a non-empty linked list representing a non-negative integer without leading zeros. Okay, so here you see without leading zeros. Return the head of the linked list after doubling it. So I'm assuming that this means in place. So first I'll start off with a wrong solution. Uh, just so that you don't make the same mistake that I did. So we have a linked list like this. So we have 1, 8, 9, and we're supposed to return the linked list after we double it. So double of 189 is 378, right? So let's 7, 8. So this is the head that we're supposed to return. So what I thought in the beginning was that first of all, I'll convert this. I mean, I'll just, go through this linked list. And I made a string of all the characters that appear in the linked list. Like, for example, I made a string 189, converted it into an integer, and then doubled it. And then took this number and then made a linked list out of it again. So the problem with this was that it gave me a runtime error. And the reason was that, so I'll just show it to you. So yeah, so it exceeds the limit for the integer string conversion, right? So if suppose the length of the string that we're passing to the int function to convert it into an integer is more than 4,300, then Python does not allow that. So I could easily just change it by, storing it as an array and doubling it there instead. But then I think the point of this question is to do it in place. So it's easier this way. So let's see how it works, right? So this is essentially the same as adding two numbers that are represented as a linked list. So we're adding a number to itself. That's it, right? So for example, here we take the first example that they gave 1, 8, and 9. So we need to add 189 to it. So if we do it normally, just forgetting that it's a linked list and we'll add 9 and 9, we say 8 and we do one carry, 16, 7 and one carry, and then 3. So this would be our answer. So if we take an example of a case with like an extra digit where the length of the answer that we get is different from the length of like basically doubling as a digit. Like for example, 998, the double of 998 is 1998, right? So it's as simple as that. So if we consider it as a linked list, then what we're doing is we're starting it from the ending, right? So if we take 998, yeah, so we're starting from the ending. So to 8, we to this node we add whatever is the value in this node itself. So to 8, we should add 8, right? Then whatever we get here, we'll get 16 over here. So because this 16 is greater than 10, we only store this digit. So we change this digit to 6. And then we say that the carry that we have is 1. So again, to 9, we will add 9 itself. And we'll add all of these three, the carry and the digit to itself. So 18 plus 1, 19. We stored 9 in its place. And we carry 1 again, right? So now we have 1 and 9. And we also add 9 to itself. So we get 19 again. So we have to change this value to 9. And we get an extra 1 carry. So that means that we'll need to create an extra node over here and connect it to the rest of the linked list and update the new head. So it's just like inserting a node at the beginning of the linked list. So that's it. So the catch for starting from the ending is just to use recursion, because recursion uses a stack. So that means that we'll be performing the operations from the ending. So the code is simple for this. Let's look at the right code this time. Sorry, this is not the one. Yeah. Yep. So I'm having a function f. Again, this is a terrible name. Don't use f. Use something better. I'm calling the function f and I'm passing it the head node that they've given me in this function, right? So I was taking the head node or the current node, and it's checking if the node exists. If it's not, none, basically. And then instead of doing anything, it's just directly calling the cur.next. So it is just skipping to the next node. Why is that? It's because we want to start from the ending, right? So if suppose consider 189 and I've called my f on 1. That means that we're over here, right? I've called f on 1. We're over here. This is not the last node. This is not where we should start performing operation from. So we'll go first to 8. We'll check if like there's a next, there is a next. So we'll go to 8. Does 8 have a next? It does. So we'll go to 9. And from 9, we will start whatever is there below over here, whatever is code is there. This will start executing. So we're saying that we're saying current.val is cur.val into 2, which is we're doubling it, and we're adding the carry to it. So we're checking if this resultant is greater than 9. So that means that we should update our carry, and we can only have one digit in the linked list, right? Because each node here represents a digit in the number that we're looking at. So we cannot have like a value of 10 in one particular node. So for that, we're just storing the last digit, and then we're updating the carry to be 1. Otherwise, we know that the carry will just be 0, right? So here carry is a static variable, and that's because it needs to persist between function calls, right? For example, see over here, we're adding 9 and 9. Initially, the carry is 0, right? So we'll do 9 plus 9 plus 0. And so we had to update this value to 8 because we only stored that digit, right? Percentile try to get the digit. And we know that the carry is 1. So we change the carry here to 1, and then we add 8 to 8, and we add it to 1, which is the carry. And we repeat the same thing. So that's it. If we understand that if we need to use recursion, then that's it. We get the solution. So in the end, we check if the carry is 1. If it is 1, that means that we need to add an extra node at the beginning of the linked list, the case that we discussed where, if we have 998, the answer that we get is 1998. So we just check if the carry is 1. So if there's a residual carry, we make it the new head node, and we return that. Otherwise, we return the normal head. So that's it. I hope you understood my solution. Thanks for watching.